welcome. Today we are in the eastern part of Gujarat where we are looking at the Aravalli mountain belts and part of that. Today we are looking at Shivrajpur area, and with me is
This is an example of a low-grade metamorphic terrain, usually a polymetamorphic terrain. Basically, I am working on hard rocks metamorphic. So it has undergone two phases of metamorphism. It's regional metamorphism, and then later on, this plutonic intrusive activity has led to the development of another phase of metamorphism. That is the development of contact metamorphism. So overall, if you look at this Japanese group, so the eastern side is more dominated by this granite and the metasedimentary contact. So therefore, you are getting a lot of evidences of contact metamorphism. From east to west, when you move, that gradually reduces, and more you will find the effect of regional metamorphism over the region. This metasedimentary rock happens in six formations in all. One of the formations is more having a concentration of manganese. That is what erstwhile it was famous for, right? Japan. So that's why people have earlier workers have related this archaeology like that. But of course, the present age is geology.
this is another section uh, beyond what we had earlier seen, and as you can see, these are very tightly folded structures in which you can see one fold or an anticline with several smaller anticlines also. This is a very nearby section where we can see thin beds of quartzite which are tightly folded, and as you can see here, there is this incline which is very sharp folded. With me is Dr. Joshi, who is an expert of this area. He did his work on structural aspect of Shirajpur area. Yes, Dr. Joshi, what you can tell us about this area?
Hello, very good afternoon to everyone. Today we are in the uh, youngermost sequence of the Aravalli domain. This is particularly called as Chapanir group, which is the youngest group to the Aravalli supergroup, and which has been divided into the six formations, out of which we are in the Shivrajpur formation, which is very well famous for the manganese deposit in this particular region. Now, in my backside you can see a beautiful folded structure, and this particular rock consists these manganese deposits which are indicated in black color. So whatever black portions that you are able to see in this outcrop, that is altogether the manganese deposit. Some of the peculiar things that you can observe in this rock, that the rock is interbedded kind of. It's a intercalated sequence between quartzites and phyllites. So the thinly laminated or the phylitic layers that you can see which are present, which are interbedded with thick massive quartzites, and in those quartzites, if you carefully observe, there are again primary laminations, that is the S0, which are typically being seen, which are indicated by the alternate layering of light and dark color minerals. The folded structure that you are able to see over here, it is particularly the tight fold, uh, having an interlimb angle around 25 degrees, and this represents the D1 deformation of the Japanese group. There are total three phases, out of which the D1 deformation of the Japanese group is very well persistent in this particular.
So Aditya, where does this fold axis lie for this? Can you just point out?
Yeah, over here, if you see, the fold axis is somewhere over here.
Okay.
And you can see very well that the fold axis is also plunging. The fold, if you just try to reconstruct in 3 dimension, the fold axis is plunging in this direction, so entire folded structure is dipping like this, in this manner.
Okay. So is this plunging related to the first phase or second phase,
Yes,
or what?
it is related to the first phase of the deformation of Japanese.
Okay.
Because intense deformation has been observed. More or less tight folds are observed in the first generation folds of the Japanese region.
And this is what we had discussed. Aditya is sitting on a limb of a syncline, and as you can see, the fold axis, this is the plunging syncline you're looking, and the core was manganese rich. Am I correct, Aditya?
Yes, yes. Actually, the area represents over here, the mechanism of folding is dominant as buckling mechanism, and these are interlayer or multi-layer buckle folds you can see. Now what happens, this is mainly associated with one more mechanism, that is flexure slip folding, in which the limb portions get thinner and the hinges are broad or thickened. So whatever mass from the limb portion has been concentrated to the hinge portion, and for then mining this manganese, it becomes more easier. So they just have to puncture the hinges and just they have to take out the manganese. So whatever sink forms or synclines or anticlines that you will find in this area are typically being punctured like this, and they have extracted all the manganese from this region. So this is an excellent example, or the area in which we bring this particular area where we bring the students, we show them this is an excellent example of this is mineralization is there, and it is completely governed by the structure. So it's structurally controlled mineralization.